Let's look at the Bohr's theory of hydrogen spectrum. Now, I have several concepts to explain in this video. If you are new to this channel, kindly click the subscribe button and the notification bell. So when I release any new video, you get notified. All right, let's look at the hydrogen spectrum. Now, what do we mean by the word spectrum? What is the meaning of this word spectrum? You see, spectrum represents what? Range of colors of different wavelengths that are often produced when white light is what is split by a prism. That is what they represent, what range of colors. Spectrum are what they are range of colors when light is split by what by a prism. Take a look. The closest spectrum to you that you observe sometimes is what we call what the rainbow. Observe the rainbow has what 7 colors. So rainbow is an example of what of a spectrum because the sunlight is what is split into what into 7 colors of rainbow by the droplets of water that you can find in the what in the atmosphere. So a rainbow is an example of a spectrum. All right. Now, what do we now call what hydrogen spectrum? You see, the scientist Neil Bohr, he accounted for the series of lines that are what that are observed in the hydrogen spectrum. Excuse me. Now, take for instance, you see, when hydrogen is put in a discharge tube, we observe several lines. And the scientist that explained all these several lines, that accounted for those several lines, is what we call what? We call him Neil Bohr. Now, he explained that you see the first line that you can see here with energy level n equal to 1 is called the Lyman series. The one with energy level n equal to 2 is called the Balmer series. This is called the Paschen series. This one is called the bracket series. And here we have the Pfund series. You see the last series also, we have the Humphrey series. The Humphrey series, exactly. Now, these are the series of lines that are observed in what? In hydrogen spectrum. Now, take note that I said something that was spectrum are range of colors that have what? Wavelengths. Now, how do we get the wavelengths of these spectral lines observed in hydrogen spectrum? How do we calculate the wavelength of this line? Now, take note of this formula. You see, to get the wavelength, we have 1 over lambda, which is the wavelength, equals to, you see this R is called Rydberg constant, 1 over n1 square minus 1 over n2 square. You see, this RH is called the Rydberg constant. And this constant is 1.097 times 10 raised power 7 per meter. That is it in meter. And take note that what all this quantity here, they are all equal to the wave number. This is called the wave number. Now, take note that this is how we use this formula. You see, in this formula, N1 must always be less than what? Must always be less than N2. So that what you have here will be a positive quantity. Take note, our lambda is always positive. It cannot be negative. So N1 that you are going to use here must always be less than N2. That's it. So whenever I'm considering, you see these lines, let's explain these lines. You see, it's possible for electron to fall from all this energy level into the first energy level. You can see this one here is falling from the second energy level to the first. The next one is falling from the third energy level to the first. This one also is falling from the fourth energy level to the first. So if they are falling to the first energy level, it means that they are contained in the what? In the Lyman series. Similarly, if this other one fall in the second energy level, they are contained in the Balmer series and so on like that. And take note that the Lyman series is at the what? Ultraviolet region. This one, the visible light region. While all other ones here, they are what? The infrared region. We have the infrared what? The infrared what region. Good. So whenever you calculate and you have your n to be 1, so take note that what? That electron is found in the what? In the ultraviolet region. And that is it. So this is how we calculate the wavelength of the lines, the spectral lines of hydrogen. So that's that about that. So take note that according to Niels Bohr model of atom, it stated that electron revolve around the atom and they exist at certain energy level. Remember, if this is the nucleus, this is the first energy level and this is the what second energy level. And take note that this energy level are always whole number. They cannot be decimal number, and that's what we call what discrete values. Discrete values are always whole number. They are not decimal number. You see, decimal number are what continuous data. While whole number are discrete data. So take note that what this energy here they are quantized. You see, when you hear the word quantized, it means that what it can take only discrete number. Okay, it can take what only discrete number and not continuous data number like that. So that's it. Okay. Now, take note that Niels Bohr proposed that what these electrons don't radiate energy when they are in this energy level. But what happens when there is electronic transition? When electron want to move from this first energy level to the second energy level, or from a lower energy level to higher energy level, what happens? It will absorb energy. So this one like this now, it has to what? It has to absorb energy. Why this one that is falling from higher to lower, it will have to what? It will have to release energy. It will release what? It will release energy. And that's the concept. Now, take note of this fact that there's a particular theory we call the Planck's theory. And it's telling us that what the amount of energy that can be released whenever there's an electronic transition, we have the energy to be what? E equal to what? HF. We can calculate the amount of energy by E equal to what? HF. But whenever we are given the energy level, take notes, use this formula. E equal E naught 1 over N1 square minus 1 over N2 square. So it's possible once your energy is negative, note that it is what? The electron is radiating energy. But whenever your energy is positive, it means that it is absorbing energy. And what is E naught? E naught is the energy in ground state, and it is what? It can be 13.6 electron volts, or it can be 2.18 times 10 raised power minus 18 joules. Take note of this fact that 1 electron volt is equals to 1.6 times 10 raised power minus 19 joule. So that's it. So that is about the Bohr's theory. So this is what I want us to take note of, that whenever hydrogen is ignited in a discharge tube, it shows some series of lines, which are this one listed here. So the one with n equal to 1 is Lehman, n equal to 2 is Balmer, and so on like that. So this is ultraviolet region, visible region, all other ones are in infrared region. So this is how we calculate the wavelength, and this I will calculate what the energy that is being released. So that's that about that. So in my next video, we are going to solve question on this. So let's test our understanding. Thanks for watching.